Mr. Ian,
Yes, sir.
how do you check this out?
Sneakers.
Oh, thank you.
You check the sneakers?
Oh, the sneakers.
Yeah.
Yes.
Can you kindly speak into the mic?
I can speak into
Okay,
the
you might
mic.
stop saying things. I don't know why I'm saying things.
Can you hear me?
Oh, maybe check out these sound settings.
I think I can hear myself.
Oh, I know, yeah.
Maybe that wasn't me.
The sense of what was Mr. Dow. What? Little Mr. Wally. What are you saying?
The signs of wow with Mr. Dow.
The signs of wow with Mr. Dow.
The signs of
This guy's saying, "Oh, don't worry, not the record."
Maggie
Hello, syllable.
Sound check.
You can speak into the mic.
sound check. Okay, I'm sounding. I'm not sure how I'm sounding, but I'm sounding.
Kusenza one ka
Can he
naman.
hear himself? There we go. There we go.
Great. Okay,
The microphone.
sir. Okay.
It's a good thing I brought 2 candles because one of them is going to finish before we even start.
It would blow it out and like relight it. Is it one of those where it might not light again? Oh, it's the magic.
Jimmy.
Alright, I left my blowtorch. Like a blowtorch can light a candle. We should try that, we should try that experiment.
It's gonna kill us the down right
See if
now.
a blowtorch can light a candle.
Fit. Better.
Now that does not sound better.
They always say, "No, that sounds good."
Well, logo, do you want the logo, Mr. Ian? Or should we do it? Is that logo? Is that
Do
logo?
we leave the logo or do we remove it?
Is that logo?
When in doubt,
Sharp.
I'm confused now.
we removed it. It's fine.
January.
It can always be added
So
digitally.
we're going to
Oh,
take
but
these first.
So we start with that one. Eh? Eh. The thing I come in going to say.
Can you see that?
Yeah, sure. Sure.
So I'll know roughly where to go. I'll know roughly to go somewhere here.
Some of that's fine.
Okay. And then I want to bring the white one in to show them as well. This one has nothing inside. Okay, are those shots good enough?
Yes. We can start with the intro.
Okay. Good afternoon, and welcome to another episode of Science of Wow with Mr. Dow. Today, we're going to primarily focus on heat movement, and I'll not try and speak out some of the common terms used in science concerning heat movement, for I feel it's better that any students out there who want to learn about heat movement should do a little bit of investigation on their own and familiarize themselves with some of the terminology that's used in science to describe heat as it moves through various mediums like solids, liquids, and gases. So without further ado, we'll do 3 experiments today concerning heat and its movement. The first one, you're going to need a candle, 2 balloons, one of the balloons filled with water, the other one filled with air. So in the first part of this experiment, I'm going to take the little candle that I have and light it. Once the candle is going, we can take the balloon that's filled with air and bring it over the candle. And what should happen is the candle explodes. It exploded so violently that it blew out the candle. So we'll relight the candle. And I'll take the second balloon that has approximately 100 milliliters of water inside it and bring it down over the candle. And we can see that actually nothing has happened. The balloon is intact, the water is inside, and the candle is still on. The question is, why? I'm sure the students can observe what is actually different, aside from the color and the size of the balloon, that there's water inside the balloon, but what effect is that water having on the balloon? That is apparently for you to decide and to find out. Okay? The second experiment, which is very, very similar, but using different equipment, and I might add, this equipment is easily obtained by anybody at anybody's house. The first piece is a piece of paper here. The paper is hollow. It's taped together by sellotape. And watch what happens when I bring it close to the flame. I'm about 2 centimeters away, and we have the piece of paper in 5 seconds on fire. The same or similar piece of paper, and I'll show you by taking it off an empty bottle, glass bottle, no labels on it. And we insert the glass bottle into the paper, and I'm sure everybody can see everything else is similar, it's the same. And watch what happens when I bring it down to the candle. Five seconds, the paper is not burning. 10 seconds, the paper is still not burning. Let's have a look and see if it's even marked. Not even a brown mark, not even a soot mark on the paper. So again, why does this happen? We would have expected the paper to burn, but it hasn't. In fact, it's showing very little sign of anything happening to the paper. What effect does the bottle have on the paper? That is a question for you to try and find out. The third and final experiment, I'll need another candle, roughly about the same size. I have a disinfectant, a sanitized bottle, still with some of the sanitizer inside. And I'll put that just to the side of the candles. A piece of grass with a little bit of a toothpick at the end, and a nicely cut out design from an ordinary black piece of paper. This design is shaped like a spiral or a spring that comes down to one point. So what I'm going to do is place it on top of the spiral and watch what happens. And we have current coming in here. Sometimes things don't go exactly as we plan. Can you get it twisty? And then it falls. I don't know, did you pick that up?
Yeah.
Did it twist it around?
Oh.
Oh. Okay. Just, that might have an effect as well. And I think that's as good as we're going to get. Okay, let's just stop for a sec. Ah, I actually see what's happened. Sorry. There was a hole at the top that it was. Moving. Yeah, one more time.
Is there any way you can make the camera even look a little bit down so that we avoid that space? Just show him. And hit StreamYard on that other screen.
Well, the other thing is, what normally works better, but I didn't have the
Yeah, that's it.
the thread, was you put a piece of sewing thread through the top, and it can spin on the
All right.
sewing thread until it gets so tight that it doesn't move anymore. You see, now it's going better.
That's what we do, actually. And then it's gonna cut to
So we now have just about to fall off the spiral-shaped paper spinning freely due to the movement of the heat generated by the candles. And if I take the candles away, it should actually stop. And there we have it. Yeah, you see, nice thing in science, if at first it doesn't succeed, you keep trying again. Eventually, it will. So scientists, generally speaking, don't give up very easily. And you can quote me on that. No, you can't. All right. So those are the heat ones. Can I do the last one?
Yes, sir.
Do I need to? Do I need to reintroduce? Natasha.
That's a baby girl.
And thank God she looks like her mom, or resembles more her mom.
But I think she looks like you,
Mm-mm.
physically. Yeah? No?
Mm, I think she has more of the beauty of Africans than Makoa. And Cheshire is like a carbon copy of Mamba.
Splits, huh?
And Timisang, unfortunately, is kind of half, half.
Yeah. I haven't seen things on
Nice. He's a nice kid. All of the kids are good.
Yeah.
I adore them all. Okay. So, do I have to go through the readings again?
No, but we can always cut from
Okay.
first
So
episode.
I'll just say in this last experiment. I'm going to have to come in, I think, on,
Tuesday.
or maybe even Friday.
Okay.
Friday morning. Would you be,
Um,
or even tomorrow? I can do tomorrow at this time. Would that be all right?
Yeah.
Just to do a couple of other.
no, tomorrow. Tomorrow's fine.
Tomorrow's fine. In the afternoon. Okay. Just to do a couple of other really simple.
Yeah.
Really simple ones. All right. And we didn't burn down anything.
It's a plus.
I'm sorry I made a bit of a mess with
Thanks, okay.
paper.
How was you the last one?
Yes, sir.
Okay. I don't know if
Just
will you be able to pick this up.
Yes, it's visible.
Okay. And at times it even works with something like this. And can you get this? Can you see? And you can see there's water.
Yes, sir.
Okay. Do you want to start?
Yes.
Okay. For the last experiment today, we're going to change our focus from convection. Oops! I gave away one of the terms.
We'll cut it out.
Heat movement. We're not going to focus on heat movement. We're going to take a look at some forces that are common in our daily lives. In this experiment, you'll need a glass that has a fair size opening. You'll need ordinary tap water. You'll need a piece of smooth plastic, fairly stiff, but not really stiff. So you can probably get something like a cake cover and cut it. I find if the glass has got a round mouth, it works best to keep that shape and just make it slightly bigger than the glass itself. What I'm going to do is fill the glass up with water. So there's about 200 to 300 milliliters of water in the glass, right to the very rim of the glass. And then I'm going to take the plastic piece and put it on the top, like this. Gently push it down and turn it over so that, oops, didn't work so good, so that it stays on the table nice and flat. Let me move it away from the water. And we're going to have to clean this up, huh? So we'll stop. Because,
It's gonna slide off.
yeah, it will slide off. So, I'm sorry. Again, sometimes sometimes things don't go the way they should. Possibly it's old, non-flexible fingers. I wonder who he's talking about. Not you, not you, but oh dear, it's me. Oh. No, it's actually fun getting old.
Isn't it?
Well, it's different. It's an acquired taste. Okay,
For sure.
so I'll go back to let us top up the glass with water so that it goes right to the rim of the glass. And we take our disc and make sure that it's free from a lot of dust and dirt. And then I place it on the glass. Hold it down relatively tight so that none of the water escapes. And we sit and we hope that when I remove my hand, the water does not come out of the glass. Now, when you think there's 300 milliliters of water inside, that roughly equates to about 300 grams of mass in water. And it should be pushing hard enough on the plastic to make it fall, but it doesn't. And I can shake it. I could even put some weights on the outside, but for now, I think we'll just leave it at this. We have a piece of plastic, very small, that's somehow stopping the water from falling out of the glass. Clearly, there's a force at work here, or forces at work here, that need to be further understood. I'll leave that up to the learners, and we'll say goodbye at that. Thank you very much. Please tune in again for some more Science of Wow with Mr. Dow. Okay, yeah, you see, second time is a bit better. What about if I put it down on the table? Ah, can you see what's going in?
Yeah.
Mm. A little bit of what? Air.
Yeah.
But not enough to make it actually slide off.
I was thinking about the equipment.
Yes.
Oh, we are so bad.
Oh my God, that's
Mm.
please, electricity.
Yes,
That was great. That was great.
good. So,
Yeah, I think that one gave me goosebumps because
It's just like, yeah.
actually, you know, sort of, I've done it with a 5-liter bucket
oh yeah,
and then
with plastic.
a piece of Perspex.
Oh yeah.
Grams additional weight on the Perspex, and it didn't come off.
Whoa.
5 kilograms, and it was all over the place.
Wow, that's interesting.
Hmm.
So what if you poke the plastic? Pinch it.
What if you were to poke a hole here?
Yeah.
The water wouldn't come out. What might happen is a little bit of air would go in,
Yeah.
a little bit, but not much. So
Sorry, I'm a geek, so
there's actually
get excited about it.
there's actually
She looks pretty.
quite a bit going on because the water has mass, so gravity's pulling down on it. and it should be 300 grams of force pulling down. Something's pushing up to keep that plastic there. And there's even another force going on there that we looked at before, suction force. So you've got suction, you've got something, what's that something that's pushing up?
Hmm.
We'll leave it to the students.
You know,
Hmm.
is pushing up. And everybody forgets that air is moving. But a really clever kid will say, but hang on, there's also air pushing down as well.
So would you say today's lesson was what? Combustion, conduction, and what's this one?
There was heat movement, so it's convection and conduction
Conduction.
going on. And then this one was more about forces. So there's the
Resultant
mass that's inside, and gravity's pulling that down. So something has to counteract that. In fact, not just counteract it, but push back harder to keep it from coming down. And there's a couple of forces that are doing that.
That's good.
Not just one pulling down, but a couple of forces.
I wanted the outtakes, like after the little clip, like explanations and stuff.
What's it called?
Outtakes.
Outtakes.
Like in the movies, like if the actors are done with the scene and then
Yeah.
they're discussing the scene or they made mistakes, like you guys call them bloopers. Stuff.
Yeah, bloopers.
Like outtakes is when you're actually making sense of
Yeah,
something.
that's it like
Hey, whatever, you guys didn't mistake.
Okay, so thank you very much.
Thank you, Mr.
I-
Dow.
In trying to keep it short, it would be nice to one day just kind of come and show